On the 1st of September 1859, a telegraph operator in the eastern United States sat down to a normal morning. The wires that carried the world's fastest messages hummed quietly, the way they always did. Then they came alive. Sparks jumped from the brass keys, paper tape smoldered on the desks. Operators felt a shock run up their arms, and when they disconnected the batteries, cutting the power completely, the machines kept sending. Something else was driving the wires now. 93 million miles away, the sun had turned toward Earth and, for a few hours, reached down and taken hold of the newest technology on the planet. It has never really let go. And the world it can reach now is nothing like a room full of telegraph wires. The morning of that storm, an astronomer named Richard Carrington was doing what he did on every clear day, sketching sunspots projected onto a screen. Just before noon, he saw something no one had ever recorded. A sudden flash of brilliant white light on the surface of the sun. It lasted only a few minutes. About 17 hours later, the Earth was in chaos. Curtains of red and green light, auroras, spilled far past the poles, all the way down to the Caribbean and Central America. In some places, they were bright enough to read a newspaper by. People woke and thought the sun had risen early. Carrington made a leap no one had made before. The flash he had seen on the sun and the storm now wrapping the Earth were the same event. The sun had reached across space and touched the planet. In 1859, that touch cost the world a few damaged telegraph lines. A curiosity, a good story. But the wires were only the beginning. In the century and a half since, we have wrapped the entire planet in the same fragile thing. Metal, carrying current, over long distances. The power grid, cables under the sea, pipelines, and above us, thousands of satellites that everything now leans on. Navigation, banking, communication. The quiet timing signals that keep the whole system in step. So here is the real question. Not whether the sun will do this again, because it will. The question is, what happens when it does? To us. To understand the danger, you have to understand what actually crosses the gap. The sun does not simply shine. Sometimes it erupts, flinging a cloud of magnetized gas out into space. Scientists call it a coronal mass ejection. Picture a billion tons of the sun's own atmosphere thrown outward at millions of kilometers an hour. When one of those clouds is aimed at Earth, it arrives in anywhere from about 15 hours to a few days. Most of them wash over us harmlessly. But if the cloud's magnetic field is pointing the right way, opposite to Earth's own, it locks on. And a storm that locks on can drive electric currents through anything long and metal on the ground below, including the power grid. This is not a theory. On the 13th of March 1989, a solar storm reached the power network of Québec in Canada. The long transmission lines ran for hundreds of kilometers, and to the storm, they looked like an antenna. In less than 90 seconds, the entire grid collapsed. 6 million people lost power in the middle of a winter night for 9 hours. Quebec was a warning, and it was nowhere near the worst the sun can do. On the 23rd of July 2012, a solar storm at least as powerful as the one in 1859 tore across Earth's orbit at full force. It missed us, but only by luck, and only by about a week. Earth had been sitting in that exact spot in its orbit 7 days earlier. Instead of striking the planet, the storm hit a NASA spacecraft called Stereo A, which was built to survive it and measured the whole thing. When scientists worked out what would have happened if it had arrived a week earlier, the result was sobering. A storm about twice as strong as the one that blacked out Quebec. One of the researchers, Daniel Baker, put it plainly. If it had hit, he said, we would still be picking up the pieces. And even the Great Storm of 1859 is not the ceiling. Locked inside the rings of ancient trees are the chemical fingerprints of solar storms far larger. One in the year 774 was at least 10 times stronger than Carrington's. The sun has done worse. We simply weren't here, wired to the wall, when it did. So how worried should we actually be? This is where careful scientists begin to disagree, and the disagreement matters. The first question is, how often? Some estimates, based on the long historical record, suggest a storm the size of 1859 comes along only once in several centuries. Another widely cited study looked at the numbers differently and put the odds at around 12% in any given decade. Roughly a 1 in 8 chance. Those are two very different futures, and no one can yet say which one is real. The second question is, how bad? One influential worst-case study imagined a severe storm striking the modern grid and estimated the damage in the first year alone at $1 to $2 trillion, with some regions taking years to recover. The most fragile point is an odd one. The giant transformers at the heart of the grid are each custom-built, and a single one can take more than a year to replace. Other engineers think this picture is too dark, that with enough warning, operators can protect the grid in time. That argument isn't settled either. Step back from the worst case, though, and there is a great deal of solid ground. We understand what these storms are and how they form. We watch the sun constantly, from the ground and from space. And we keep sentinels, spacecraft parked about 1 million miles out, directly between us and the sun, tasting the solar wind as it streams past. We have also learned to live with the smaller storms. In 2022, a fairly ordinary one warmed the upper atmosphere just enough to drag 38 newly launched satellites back down to burn up. In May of 2024, the strongest storm in 20 years lit auroras over deserts and cities that almost never see them, and scrambled the navigation on farm tractors in the middle of planting season. That time, the grids held. But those same sentinels reveal the real gap in our defenses, and it is a strange one. We can see a storm leave the sun days in advance. What we cannot see, until the very last moment, is whether it is aimed to do harm. The one detail that decides everything, the direction the storm's magnetic field is pointing, only becomes clear when the cloud finally reaches those spacecraft 1 million miles out. That gives us somewhere between 15 minutes and about an hour of real warning. 15 minutes to an hour to protect a civilization built on the grid. So the honest answer is this: we know it will happen again. We do not know when. We do not fully know how badly the grid would break, and we would only know the worst was coming in the final hour before it arrived. In 1859, the sun reached down, lit up the sky, and shocked a handful of telegraph operators. Then the world went back to sleep. There was almost nothing yet for it to break. We built the rest. Every wire, every satellite, every quiet signal that keeps the lights on and the money moving and the messages flowing. All of it in the time since. Tonight, the grid is humming. Somewhere out toward the sun, a small spacecraft sits in the dark, tasting the wind, watching for the one that matters. The sun has done this before. It is patient. And for now, the lights are still on.